has good exposure. He has good exposure in working with several international and Indian clients and worked actively on improving production, data quality, data standards, data completeness. He has automated and simplified workflows by applying principles from machine learning, artificial intelligence, natural language processing, computer vision, image processing, and knowledge graphs for increasing the business productivity. With this brief introduction, I welcome you, sir, to the session. Thank you one and all for giving me this opportunity. And now I hand over the session to Sirisha.
Thank you, madam. Now we cordially invite the resource person, Mr. K. Chaitanya, to continue the session.
Thank you, one and all. Am I audible?
Yes.
Okay, thank you. Thank you. I've started sharing my screen. Let me know once you're able to see my share. Are you able to see my share, sir?
Yes, sir.
Okay, thank you. Thank you so much. So this session is all about real-time applications of classification techniques in data science. So let me give you a quick introduction of mine. So our speakers have already given an introduction of mine, but let me tell you just in a minute. I'm actually working as a principal R&D engineer in a product development company called OpenStream. So my overall experience is above 13 years, and out of these 13 years, I was associated with Infosys for more than 10 years. So my skill set include machine learning, AI, NLU, computer vision, image processing, and so on. So I also have a hands-on experience in Microsoft stack like SharePoint, Office 65, C#, .NET, and so on. So I'm about to submit my thesis in NIT Warangal. I'm doing my PhD from NIT Warangal, and I've written more and I've written many ACI journals, Scopus, and some research papers, and I've also presented them at some international stages. So today I'm going to actually introduce you to some of the concepts of classification, and also I'll also explain you a classification solution that we had got or that we had framed for addressing a real-time problem from oil and gas industry. So coming to the classification, so this is just the introduction of the classification. So it belongs to machine learning field, where the main intention is to identify a label for each point that's there in the solution space. So classification refers to a predictive modeling problem where each class label is identified for a given for a given example in the training in the input data. So some simple classification problems include identifying an email, identifying if an email is a spam or not, or identifying the user's behavior if it's a normal behavior or an abnormal behavior, and so on. So we use this classification in our daily life, and it's one of the most basic thing that we do in the real time as well. So coming to the types of learners in the classification, we have two types of learners. One is the lazy learner, another is the eager learner. So this lazy learner in the classification, right? So it actually stores the training data. It only stores the training data, and it applies that stored training data on the testing data when it comes. So one example of the lazy learner classification is a k nearest neighbor classification technique. And the second type of learner in the classification is the eager learner, where it's actually constructs the classification model by taking the input training data into consideration, and it applies the trained classification model on the test data, and it identifies the class label. So some of the examples of in this category are decision trees, naive Bayes, and artificial neural networks. So in my next subsequent slides, I'll also introduce you to all these kind of classification techniques, and so that you'll get more insights. So coming to the classification tasks, so we have four main classification tasks that are available now. These are the most important classification tasks. One is the binary classification. Next is a multi-class classification. The third one is a multi-label classification, and fourth one is an imbalanced classification. So there are also other types of classification techniques, but they're all that they all fall into any of these four major classification areas. So coming to the binary classification, it's just identifying if at all um, uh, uh, if so, so the outcome or outcome of the binary classification is to classify a given point among two different class labels. So examples being identifying if a spam is identifying if an email is spam or not. So so the outcome of the binary classification is only 1 or 0, or choosing between true or false and something, and so on. So typically in binary classification, one class is a normal state, another class is an abnormal state. So coming to our email spam detection, so having a label called non-spam is a normal state, but having a label called spam is an abnormal state. Similarly, having cancer having cancer is an abnormal state, and not having a cancer is an abnormal state. Uh, so some of the popular algorithms in binary classification include logistic regression, k-nearest neighbors, decision trees, SVM, naive Bayes. So some examples, some algorithms are specifically designed for binary classification, and they do not natively support more than two classes. Some examples include this logistic regression and support vector machine. So they are only used for the binary classification technique. So it's actually our main intention are going into the details of this binary classification. So a model that we are building should predict Bernoulli probability distribution for each example. So coming to the details of Bernoulli distribution, so Bernoulli distribution is actually a discrete probability distribution function that covers a case where an event will have only a binary outcome, which is either 0 or 1. Yeah, coming to the multi-class classification, refers to a classification which actually which have more than two class labels. One example is the phase classification, wherein which the intention is to choose the nearest phase from multiple available phases. So the number of class labels in this multi-class classification can be very large. Can be very large. So just like the binary classification, where we model the classification as a Bernoulli probability distribution, so this multi-class classification can be actually modeled as a multi-Nolly probability distribution. So in multi-Nolly probability distribution, so it's also a kind of discrete probability distribution function, so which has actually a categorical outcome, as opposed to binary classification, where we have only two outcomes, which is either 0 or 1. So in this classification, the model predicts the probability of an example from the test set that would belong to multiple class labels. So some of the popular multi-class classification techniques are KNN decision trees, naive Bayes, and so on. So it also involves a strategy of fitting multiple binary classification models for each class versus others. So there are actually two types of um, multi-class classification techniques that we can apply. One is called one versus rest, another is called one versus one. In one versus a rest, we fit a binary classification model for each class and compare it with all the other classes. Whereas in one versus one, we fit a binary classification model for each pair of classes, and we use the result of this for identifying the class label for a given point in the test set. When coming to the multi-label classification, this is a third type of classification techniques that we use. So which actually refers to identifying one or more, or rather two or more class labels from the given test set. So one example being, if at all, if there is a photo, so we may identify multiple things in that photo. For example, it may have something, it may have a person, or it may have an object like a bicycle, or it may have another object like an apple. So given a photo, so we identify multiple labels from that photo. So that's called multi-label classification. So there are some these classification, I mean the classification algorithms that are used for this multi-class classification will be some specialized versions of the already existing algorithms. So some examples being multi-label decision trees, multi-label random forests, and multi-label gradient boostings, and so on. So meaning the already existing binary or multi-class classification techniques cannot be directly used for multi-label classification. So the fourth one is the imbalanced classification, which actually refers to the classification task where the number of examples in each class is usually unequally distributed. So it is most used, it is the most used classification techniques in the industry or in the practical terms, wherein which the majority of the examples in the training set belong to the normal class, and only few sets of the points belong to an abnormal class. So some examples of this imbalanced classification is a fraud detection, wherein which only some users will behave or will have a fraudulent action. Another is the medical diagnostics test, wherein which only some sets of or some patients are diagnosed or identified with diseases like cancer and tumor and so on. So the technique that we actually use to handle this imbalance classification is by undersampling the majority class or oversampling the minority class. So we actually take out some of the examples from the majority class or add some examples in the minority class and so on. So the mostly used models of these two which actually fall under these two categories are random undersampling and smooth oversampling. So they're the most widely used classification techniques. So I'll not go in details of this. And as multi-label classification, so this imbalanced classification techniques are also needs a specialized versions of already existing algorithms. So some examples being cost sensitive logistic regression, cost sensitive decision trees, and cost sensitive support vector machines. So which actually all these models pays more attention to the minority class when fitting a model on the training set. So this is a most widely used technique. So more attention is given to the minority class. So coming to the logistic regression. So logistic regression uh, is actually a kind of calculation which predicts a binary outcome. That is, if at all, if it's either yes or no, or 1 or 0, or true or false, and so on. It's actually a kind of machine learning technique that uses one or more independent variables to determine an outcome. So this is the most simply used or most widely used algorithm in the real time. So which actually identifies or which identifies, if at all, if a point belongs to class A or class B, class C or class D, and so on. So the goal of logistic regression is to find the best fitting relationship between the independent variables and set of independent variables and the dependent variable. So it actually predicts the probability of an occurrence of an event by fitting the data into a logit function. So that's the reason why it's called logit regression. So logistic regression has actually an equation which I'm showing here. So where x is an input value and y is a corresponding output value or the class label that is identified. So here it also takes two variables into consideration, which is b0 and b1, which is labeled as b0 and b1 here, where b0 is the bias or an intercept and b1 is a coefficient, is the coefficient. So it is assumed that each column in the input data set has these coefficients. So just an example of logistic regression: to identify the probability of a person while for determining the gender by looking at a height. For doing that, we actually find out the probability of the gender by probability of a gender by looking at the person height and confirm if it's a male or a female. So assuming that we have a problem wherein which the height of a person is 150 centimeters, so we have to identify if it's a male person or a female person. So taking these two, taking the values of B0 and B1 as -100 and 0.6 as I'm showing you here, we find the probability using the equation that I've shown and that I've explained in the previous slide. So B0 is so here X is the input as I told you. So X here is the 150 centimeters, and we calculate the value of this equation, and after calculating the exponential value, so we have got so we take the class of we take the calculated value of based on the formula, and we take the calculated value and predict the class of the point here. Since the value is closer to 0, we identify or we assume that a class is male. So it depends on the rules that we had identified before finding the probability. So coming to the advantages of logistic regression, it's actually simplest algorithm that's used. So and it is mainly used for binary classification, and it's useful for understanding how a set of independent variables affect the outcome of a dependent variable. And the main disadvantage is it only works for two classes. So which is that's why so it can't be used for classifying the data into multiple points. So that's the main disadvantage of logistic regression. And it can, and coming to the practical use cases, it can be used in classification, weather prediction, if it rains or not, or if it's a voting in voting applications, like if a leader wins an elections or not, identifying the risk of diseases, if a person is risky of getting a disease or not. Coming to the basics of the other classifier, which is a naive Bayes classifier, so which is actually based on the Bayes theorem. So the reason why it is called naive Bayes classifier is because it has two, it's because it is naive and it uses Bayes theorem for calculating the probability. So so in usual terms or most simple terms, so naive Bayes classifier assumes that the presence of a particular feature in a class is unrelated to the presence of any other features, meaning it actually thinks that every feature is independent of other features. Coming to the explanation of what is naive and what is Bayes, so it is actually called naive because it actually assumes that the occurrence of a certain feature is independent of the occurrence of other features. For example, if we have features like color, shape, and taste, and our objective is to identify identify a fruit like apple. So here, color red is mapped. Here, red is colored to the map. The spherical shape of apple is mapped to the shape, and the taste sweet is mapped to the taste feature. And since it has all matched, so it actually thinks that the fruit, the particular fruit, is an apple. So here, if we see, each feature individually contributes to the outcome, and it also thinks that they're all independent, and they don't, the outcome doesn't depend on the features. And the reason why it is called, I mean, it's called naive Bayes, as I told you. It's naive and uses the Bayes theorem. So this is the Bayes theorem which I am showing you, which is also called the Bayes rule or the Bayes law. Here on the left hand side, it is called the posterior probability, which actually which is a probability of hypothesis A on an event B. So here this part is called the likelihood probability, which actually, which is the probability of an evidence given that the probability of hypothesis is true. So every time uh, this is actually assumed as true. And again, probability of A is called the prior probability, which is a probability of hypothesis before observing before observing an evidence. And here, and again, probability of B, which is in the denominator, is called the marginal probability, which is the probability of evidence. If you see, this Bayes theorem is actually is oscillating between the probability of hypothesis and the probability of evidence to that particular hypothesis. So I'll just show you a simple example on how to on how this naive Bayes classifier works in realistic terms, and or in most simple terms. So the three steps that are actually used in naive Bayes classifiers are first converting the given data sets into its frequency tables. The second step that we do in this naive Bayes classifier is to generate a likelihood table. So this likelihood table contains a probability of an occurrence of an event. And the third step is we use the Bayes theorem to calculate the probability using the formula that I had shown you in the previous slide. So just taking this data set into consideration, so our simple problem is to identify uh, if there is a chance to play, if at all, if the weather is sunny. So we have this particular data set, so which has two columns, which is outlook and outlook in the play. So we have, these are the instances from the data set, which says that if at all, if it's rainy, we have to play, if it's sunny, we have to play, and so on. So the first step, as I told you, is to convert this data set into the frequency tables. So here, so we have so these are the frequency tables, which says that a weather forecast, a weather called forecast, is appearing 5 times, is occurring 5 times with a label called yes, and if the weather is forecast, then there are 0 occurrences in the training set with the class label no. So similarly, we take we calculate the frequency of all the all the features or all the occurrences like this, and we calculate the total of each occurrences, which are actually corresponding to class labels, which is yes or no. Here these are called the features and these are called the class labels. So as a second step, as I've told you, so we calculate the probability of each feature. So here we calculate the probability of overcast. So here the probability of overcast when combined with both yes or no is 5/14, because there are 14 for the probability of being forecast is 5/14. The probability of um, the probability of rainy is 4/14, which is composed of these two class labels, and being sunny is 5/14 again. Similarly, we also calculate the probability of being yes and being no, and we take this probability and we apply Bayes theorem. The probability uh, the probability of yes being sunny is translated into probability of sunny being yes, and so on. So we calculate the probability of both yes or yes and no using the Bayes theorem formula, and we use the final probability scores and we compare those probability scores and identify and take the decision which has more probability value. Since here the probability value of yes being sunny is more than no being sunny, so we take that or we conclude that the play should be a player can play the game. So coming to the advantage of naive-Bayes classifier, so it's actually one of the fast and most simple algorithm. So it can be used for both binary and multi-class, and it is actually the most preferred and popular choice for text classification problems. So and coming to the disadvantage, as I told you, so it actually assumes that all the features are independent and they're not related to each other. So in some examples in real time where there's a need to relate the features, there's also a need to relate all the features. So which is actually missing in naive-Bayes classifier. So it can also be used in medical data classification and so on. It can be used in sentiment analysis, and it can be used in credit card scoring. So this is one other classification technique, which is called the k nearest neighbors. So which actually takes or which projects all the data sets or all the data points in an n-dimensional space, and it considers the distance. It considers some k points for predicting the class. So for example, so if at all if we need to uh, identify the class of star here. So when k is called 3, which is k is a number of neighbors that it considers for identifying the class of this particular star. When k is 3, so it actually considers 3 nearest points from this particular point, and it takes a majority. It takes the class which is majority for the given for a given point. So here, since this orange points, which is class B, is more than the number of class B points, are more than the number of class A points, so it identifies that the star belongs to class B. And yeah, this is the most simplistic algorithm again, and the main disadvantage of KNN is that we have to first identify the value of k, which is the number of nearest neighbors, and the computation cost is also pretty high, because it has to take a point first, and it should actually compare the distance between identify the nearest points. There are multiple steps involved in it, so that's the reason why it is actually computationally heavy or computationally so coming to the use cases, so it's also used in, it can be used in image recognition, video analysis, video recognition and stock analysis and so on. So this is one important classification techniques which shows which shows the highest accuracy, which is called the support vector machine. So it can be used in both classification techniques and regression techniques. So I would actually like to emphasize 2 or 3 use cases in this in support vector machine, because it shows more accuracy when compared to the previous classification techniques. So even in SVM, so all the points are actually plotted in n-dimensional space. So where n is actually the number of features that we have. And the classification is usually done by finding the right hyperplane which differentiates between the 2 classes or multiple classes. Here we are for simplicity, we are considering only 2 classes, and the goal of an SVM is to actually plot a hyperplane. So here this is the point which is the line which I'm hovering on is actually called the hyperplane. So this hyperplane should divide these 2 points in more effective way. So there are some scenarios, some interesting scenarios in SVM as well. So here we have 3 hyperplanes, which is A, B, and C. our goal, I'll also explain you how SVM decides the right hyperplane. Here, the important goal is to identify. This is the most simplistic case. The goal is to classify. Uh, Here, the goal is to classify star and the circle. So here, this is a star and this is the circle which I'm referring to. So here, if we take hyperplane A, it is actually it's not differentiating stars and circles effectively. Same is the case with hyperplane C. But if you take the hyperplane C, it's actually the boundary between two classes. So that's the reason why it actually this point, or the hyperplane B is the best hyperplane. Coming to the scenario 2, wherein which we have three hyperplanes here, which is A, B, and C. Our goal is to identify the right hyperplane. So if you see, all these three hyperplanes are segregating the two classes well and good, but the right hyperplane is actually selected based on the margin, that is there. So here, so the main goal or the objective also to maximize the distance between the nearest data points, and which can be usually found out by finding the margin. Here, if you see the margin of if we see, so the margin of hyperplane C is actually more when compared to the margins that are there for hyperplane B and hyperplane A. So this margin, the margin for hyperplane C is more for this class and also for this class. So that's the reason why we take, since the margin is more, we consider that hyperplane C is the best hyperplanes among these three hyperplanes. So the other disadvantage of choosing, or on a flip side, if we choose a hyperplane which has less margin, then there are more chances of misclassification because when the algorithm iterates. So selecting the most or a hyperplane which has a high margin also increases the robustness of the algorithm. So coming to scenario 3 in SVM, wherein which we have two hyperplanes here, which is A and B, and taking the margin into consideration. So if you see, the margin of hyperplane A and hyperplane B are are almost the same. So if you take only margin into consideration, then then SVM algorithm actually confuses between selecting hyperplane A or hyperplane B. Then it actually selects in these kind of scenarios, it selects a hyperplane which classifies the points more accurately. So it takes the classification score during the training phase. It calculates the classification score of hyperplane B and hyperplane A, and it takes the best hyperplane which classifies or which has the better classification score. If you see hyperplane A here is the better hyperplane, because it is dividing the two classes with more confidence. And again, coming to the fourth scenario, so here this is one scenario wherein which we have the majority of the class points here, and there's one minority class point here. Here it is almost impossible for an SPM to draw a hyperplane, because assuming that it's a linear hyperplane. So there are also some other techniques which actually handles which plots the non-linear hyperplanes as well. But if we are talking about a linear hyperplane, so the SVM considers this point, which is star, as an outlier, because it is farther from other points that belongs to this particular class. So in this sense, it actually identifies that the star is an outlier. So in this sense, this SVM is also used in outlier detection analysis as well. So coming to the other classifier, which is the decision tree. So this is also most efficient and mostly used in the industry these days. So both SVM and decision trees are most important because they're used for most realistic and complicated problems in real time. So in coming to the decision tree, it actually builds a tree from the training data by applying if and then rules. So this if and then rules are actually formed based on the mutually exclusive or mutually inclusive or equally exhaustive events. So the process starts by taking all the training data at once, and it actually divides or breaks the data into smaller possible structures, and it creates a tree structure. So by day, and some rules are learned. Rules based on yes or no are learned by the classifier itself while doing the breaking. And if at all, if a rule is learned, and all the points that are following the rule are actually removed from the training data set. So this process continues until the tree is actually formed and the termination criteria is met. So yeah, so while testing a point in the real time, it actually uh, compares with the dependent point, and it takes it identifies the rules at each stage, and the and the route which has the most score is taken for the decision making. So so the main crux of decision tree is to select the best attribute for the root node, or some sub or the for next sub nodes. So there's actually a technique called attribute selection measure, so which identifies the best node for the selection among all the available nodes. So the most common techniques that are used are the information gain and information gain, um, uh, which actually calculates the measurement of changes in the entropy. So again, entropy is actually a measurement of impurity of a given attribute. So both information gain and entropy has some formulas. So uh, I'm actually driving a little fast in because I'm conscious of time. So information gain and entropy are are calculated for finding the right attribute. The second point, or the second technique that we use for attribute selection is called the Gini index, which actually calculates or which subtracts the sum of squared probability of each class from one. And the main intention the main intention while selecting the right root selecting the right attribute is to have a low Gini index when compared to the high Gini index. So again, the advantage of decision tree it is accurate in terms of accuracy because of the rules that are formed. And as I've told you, this is one important or mostly used algorithm in terms of, since it has more efficiency. So coming to the advantages and disadvantages, I'll not explain you the points in detail, but I'll just recommend some points from this table from the industry perspective, or from the practical perspective. So both decision trees are among all these classifiers. As I told you, decision trees and SVMs are most widely used because the main advantage of decision tree is that it actually supports multiple data types. So it can support numeric, categorical data, or some nominal data, and so on. So and moreover, SVM is actually widely used because it can handle multiple features. So in real time sense, in realistic data, there are really multiple features. So SVM is the most widely used. So, but if at all, if we have a limited features, then we can actually go for either naive Bayes, because it is most simplest, it is most simple algorithm in terms of calculation. So similarly, if we are doing some dichotomous tasks, so we can use either logistic regression, and we can also use k nearest neighbors, but we should be in a position to identify the k. But it can handle the noise instances very well. That's the main advantage of the KNN. So coming to the real time problem that we have, um, that we have seen in the industry. So this is one simple problem, but most widely used problem. So here the main intention is to identify the class of a document. So we don't have any information about the documents except its height, width, and so on. So we were given a set of 200K documents, and we were actually asked to identify the class. So, but the thing is, so as I told you, we didn't had any features, and we had extracted custom features from each of the file, like height, width, and size. So we took the height, width of a size, and we actually designed some custom attributes from these features. So from height, we had extracted the average height, and from width, we had extracted average width. From file size, we extracted the average file size, and we used some other attributes like height divided by width, width divided by height, and we have also taken average height and width of each file, average width by height of each file, and we also considered the file type as well, because we had multiple file types like PDFs, Word documents, TIFFs, and so on. So we have used all these attributes, and we had applied the algorithms that I had explained you. We had explained decision trees, naive Bayes, SVM, and KNN. So this is the methodology that we had used. So we had extracted attributes, which I've told you, and we also removed the abnormalities. And if the abnormalities are present, we initiated each model. We trained the model with the data that with the custom training data set that we had prepared, and we had tested with some test data. So coming to the results that we have got. So these are the classes that we have got. So which are maps, seismic sections, seismic reports, well logs, and well reports. So these are the distribution of each. These are the distribution of classes in the training data. We have close to 130 examples of each, and on the right hand side, we had also plotted the box plots for identifying the outliers. So here this point is actually identified as outlier in terms of width, and in terms of height, this point is identified as an outlier. So in this way, we had identified the outliers, and we had removed the points, and we had also plotted the confusion matrix, which actually talks about which actually talks about true positives, true negatives, false positives, and false negatives. So here from this confusion matrix, we can see a number of examples predicted by our classifier for both classes respectively. So along with from this confusion matrix, we had also plotted or we had also found out the accuracy, true positive rate, true predictive value, F1 score, and so on. So these are the formulas for accuracy, which takes true positives and true negatives and false positives and false negatives into consideration. So these values are formed from the confusion matrix, and these scores are identified for each model. So here we had also used, or we had also validated k-fold. We had validated using this k-fold cross validation. So in k-fold cross validation, we actually shuffle the data set randomly, and when we split the data set into k different groups, and we take we take a group, and we take each group. We take a group from this k groups, and we actually hold that as a test data set. So all the remaining groups will actually be a kind of training data set, and we fit the model using the training data set and evaluate on the leftover test set. So and we actually store the evaluation score for each and every group. So and we do the summary at the end, and we take the group which has the main thing. And coming to the metrics values, right? So yeah, the other important point that we need to consider for identifying the best classifier is to see the area under curve, which is actually called, which is also called or which is plotted using using ROC curve. So which is actually a kind of graphical plot which actually says that if at all, I mean, which actually shows how the classifier is behaving. So here, if it's on the right hand side, so if we see three comparisons, or the three values in ROC curve. So if at all, if an classifier is performing at its best, so its ROC curve looks like this. So if at all, if it's a poor classifier, it'll the values will be in a linearly increasing fashion like this. So a best classifier will have an ROC value, or the area under the curve value, as 1. So this is the most, this is how the ROC curve looks like for the best classifier. So coming to the results, so since we have taken attributes, custom attributes, so we had seen that SVM and the decision tree performed best. So so we had evaluated using two validation procedures, which is tenfold classification, tenfold validation, and fivefold validation. In tenfold validation, in 10 runs we had seen that SVM is the best. SVM came first for 5 times, and the decision tree came as the topmost model for the 4 times. So coming to the fivefold validation, in fivefold validation also SVM is actually the best, because it's able to draw the hyperplane correctly. And the second topmost model that we have got is a KNN, so which is for 2 times. And coming to the model's performance for 10 runs, as I told you, SVM in 10 runs, SVM actually came as the winner. And coming to the ROC curve, so this is ROC curve for the SVM. So if you see that the ROC curve of SVM is actually touching 1 here, which says that it is it's the when it had actually performed best at its yeah, for a given problem. Yeah. So yeah. So this is all I have got for today. Hello. Hello. Yeah. Hello. Am I audible?
Yes, sir.
Yeah. Yes. Yeah. This is all I've got for today for this session. Yeah. And thank you so much for providing the opportunity. I thank SRKR Engineering College organizers for providing the opportunity to share the knowledge.
Sir, will you take up some questions from the participants? If anyone has any questions, you can raise your hand. We will unmute and you can ask the question. Sir, I have a general question. Not these algorithms, but like just 1 minute, sir. Sir, nowadays in colleges like our college, BTechs specializations on data science, machine learning, and AI and machine learning and business systems are introduced from last year. What is the scope of job opportunities for the students who are doing these specializations in the industry?
Hello, am I audible?
Yes, sir.
Yes. So thank you so much for the question, madam. So the thing is, yeah, as we have been hearing, data science is now a buzzword in the industry, and due to the availability of all these techniques and availability of programming languages like Python and R and R, and along with and we all, and as we also have some tools like Jupyter, PyCharm, and so on. So now things have become more easy, and the adaptability ratio for these kind of technologies is actually the adaptability ratio is high when compared to the other technologies. So having a basic knowledge on all these and identifying the use cases and identifying the exact application areas of each algorithm is actually is needed for anyone who is looking or who wants to come into this field. Coming to your question, madam, so with all these tools and techniques and with all these resources in the internet, it's not um, there are many opportunities for the students now, but the only thing that anyone should know or should understand is that practice is needed in the field of data science. So first of all, we need to understand where an algorithm is applied, and where it can be applied and where it should not be applied. So to be honest with you, ma'am, so our literature has many techniques in terms of classification. For example, since we are talking about the classification, so we have hundreds of classification techniques that are available in the literature. So researchers have also proposed many techniques, so which actually outperforms one other model, and the research is still going on. So, but in industry, we use only standard state of the art classification techniques. So when we talk about classification state of the art techniques in each and every field, so we'll have only 5 or 6. So since the industry is also emerging in this area, so and since data science is applied to multiple domains in the industry, because one possible reasons might be each client is required to know more insights about the data. So so only the state of the art techniques are applied to the industry problems. So knowing this state of art techniques for this knowing this state of art techniques is enough to actually get a job, but these state of art techniques should be known or should be understood in a deep fashion.
Sir, one more question, sir.
Yeah.
When it comes to the programming languages, what type of languages students learn, if at all, if they want to pursue their career in this data science field?
Yeah, so the most widely the most widely used programming language is Python. So it's because of the availability of the packages sticks. So these are the most widely used the programming languages, madam. So along with that, we also have some other tools. Tools like Vika and everything, but the thing is they're not needed. So in my opinion, Python and R, they're enough.
Okay, sir. Thank you. I think we have one question in the chat window. Kavita madam is asking, please give a clear picture about the model overfitting and underfitting. Sir? Sir, can you hear me? Sir Chaitanya, sir, can you hear me? Excuse me, sir.
I'm trying to reach him. It's not audible, I believe, Chaitanya.
Okay. Okay.
I'll try anyway, trying. Probably we lost him, I believe. Probably it's the internet issue,
Sir,
I believe.
can you hear my voice?
Yeah, I'm able to hear. This is Prithvi here,
Yes,
the next speaker.
we can hear your voice. We have one question, sir, then we'll continue with the next session.
Right.
Kavita madam is asking, please give a clear picture about the model overfitting and underfitting.
Okay, so probably Chaitanya had few examples of that. It is just about how best you structure your data set such that see, it's just about giving enough data so that it is properly trained. So you need to give diverse data sets so that it will appropriately predict what is the actual result. So there could be scenarios wherein you give data wherein it actually tends to divulge the result to that threshold. I mean, it's just about how you structure the data. So either it is either there is too much data or there is very little data, because of which the model do not get enough trained, and the results might become unpredictable. So that is what is overfit and underfit. It's just either too much data or too little data. So it's just about if you start experiencing and start giving in more details, and when you actually go through these things, right, you will get to know how much diversity you will get the results when you actually do too much of data or too little data or skewed data. So when I say skewed data, right, it is actually you give data such that it will give a though the data is correct, it will give a totally different results, and for subsequent input also it will start giving different input. Probably I can show that example when I take you through a few of the examples. So in the next session, right, I can probably show you a few examples of how I'll not I'll say it is an underfit, so you'll be able to know what exactly is the problem with underfitting.
Okay, thank you, sir.
Yeah. So should I log in? I've got a different link for the next session. Should I log in there or should I continue to?
Sir, you can continue with, I think you are using Chaitanya sir's link.
Correct. Yeah, I've clicked on Chaitanya's link because he had sent me both. So I had clicked on his link.
Okay, you can use, sir.
Should I log off and log in there, or should I continue?
You can use the other link if you wish to.
Yeah, sure. I mean, whichever is convenient for you, I would be happy to do that.
You can use your link, sir.
The other link, right?
Other link, yes.
Yeah, so I'll log off. I'll leave the meeting and then join the other one.
Okay, sir.
Okay, thank you.
Sir, are you able to join? Sir, are you able to join?
Hello, everyone. Sorry, I just had few issues logging in, but I'm sorted now.
Good afternoon, sir.
Good afternoon.
So, dear participants, now we have with us Mr. Prithviraj Venkatesh, who is working as a principal R&D engineer in OpenStream Incorporation, Bangalore. I request Mrs. Sinduri Susila, assistant professor in the Department of Computer Science and Engineering, to introduce the speaker of the next session.
So good afternoon, everyone. Just a second. So first of all, I welcome Mr. Prithvi Venkatesh Garu. Welcoming you, sir, for the today's session. I'm Susila, Assistant Professor, Department of CSE, SRKR Engineering College. I'd like to introduce Mr. Prithvi Venkatesh Garu. Mr. Prithvi Venkatesh Garu is currently working as Principal Engineer, Research and Development in OpenStream with specialization in knowledge graphs, machine learning models for data extraction from where data sources, and automatic ontology generation for domain models. He worked in Infosys as Senior Technology Architect before joining OpenStream with specialization in SharePoint, Azure, Solution Architecture, and on-premises workload migration to Azure. His research areas include multi-modal virtual assistants, knowledge graphs, conversational artificial intelligence, and so on. He has over 18 plus years of experience in solution architecture, object-oriented design and analysis, with extensive experience in the full life cycle of software design process, including requirement definition, prototyping, proof of concept, design and testing, and maintenance. His top skills are solution architecture, SharePoint, and Microsoft Azure. He bagged many certifications like the Data Scientist Toolbox, AWS Academy Graduate in AWS Academy Cloud Architecting, R Programming, Reproducible Research, and Exploratory Data Analysis. With this short and candid introduction, I request Mr. Prithvi Garu to take over the session.
First of all, a big thank you. Thank you for the introduction. I would like to take this opportunity to thank the college and the faculty members and the organizing committee to give me an opportunity to talk to you all and share my experience. So today's session, it's more of a practical oriented session wherein I would actually talk about how Azure can be used in machine learning projects. So it is all about the examples which Chaitanya had shared in the previous session, wherein there was something related to classification, and there were different models discussed in the last sessions. So how Azure would help us do that, because if you look through the description about how complex these models are, you would definitely feel that there's lots of backend processes, backend resources that needs to be set up in order to in order for you to work on those models, and it would become a bit complex to set it up at the initial stage. What I'm trying to show you here is how best Azure fits into this particular domain and how it would help you in doing machine learning projects. So in this session, what I'm trying to do is take you through a few of the practical oriented examples of an oil industry, explain some of the problems, explain very briefly what an oil industry is, what are the problems that the oil industry face, and what is the scope of machine learning in this industry, and how Azure would be able to help you in few of the activities. So to start with, I'll just briefly explain what the oil industry is, so that I'll just quickly take you through the agenda. So in here, first, I would actually talk about the oil industry problems. Then I'll talk about Azure application fitment, service catalogs, which include what all the different services that Azure provides for you to help doing, be it machine learning projects or any other projects. Then cognitive skills. This is the core of Azure, wherein you have certain services which help you do data classification, image classification, speech classification, speech detection, speech translation, and many more. So, and machine learning. So some of the models which you might have actually created, you want to host them. So you might, when you create a model, you would have to definitely have backend resources for you to host them. So how Azure ML can make that experience seamless for you to create and host machine learning models is what I would talk about. I'll talk about 3 use cases. One is image classification, which we were talking earlier. Forms extraction, how we would be able to use forms. I mean, there's data which is in the form of images. How do we extract key values from there? And the last one is the well blowout. In here, I'll just briefly explain about the overfit and underfit, which we were the question that we were discussing in the last session. So in here, it is more of a Azure-oriented experience that I would be sharing. Am I audible?
Yes, sir.
Okay. I'll just very quickly explain about what an oil industry, so that it becomes an introduction for whatever problems and machine learning techniques that in Azure that we are going to discuss in the later slides. So this is a very wide view of what an oil industry is. So what you see on the left-hand side is the exploration part of it. So you see this black layer here, that is actually crude. It couldn't be hydrocarbons. When I say hydrocarbons, it can be anything. It could be petrol, or it could be gas, or anything for that matter. And that would exist. It could either exist in sea or in water. So there's lots of work that happens in an oil industry in order to find where the oil is, and it is an extremely complex task, especially when you actually drill oil in the sea. So for example, if you notice here, there's a ship which actually takes some sensors which are very similar to radars, this military radars which you might have seen in TVs, right? Which actually send some waves underneath the earth. It collects some data out of it, and that would have enormous amount of data. So for example, in less than an acre of analysis that you do, not even less than quarter of an acre, it will come to around 15 GB per week of exploration data, which means just to survey a very small area, you actually take 15 days, and that 15 days of data is close to around 15 GB, which could, I mean, the data is very huge, which means to say, in order for you to look through it and analyze and make some value out of it, becomes extremely complex. So thereafter, that's one part of the problem, which is the exploration part of it. And what you see here is actually the transportation part of it. So there's certain oil rigs here, which actually take the oil, whatever has been extracted from underneath the earth, and it will transport it to the refinery. So this again is a very complex activity because if you notice, it's actually a geo-spread industry wherein oil produced in Russia or many other different Africa get transported to either India or many other places. And if you see the complexity, right, there's lots of different stops that a ship should take in order to reach either India or any part of the world. So how do you optimize it? How do you track where this ship is? How do you stock the ship so that efficiently you manage the space or the capacity that the ship is having? So all this complexity come in, and again, there's so much of data here, right? It becomes increasingly difficult for you to manage that. So in here as well, you need certain techniques which could help you get this information very quickly, make analysis out of it, do data analysis and give the results. And the third part of it is the refinery. Again, this is one of the most complex part of it. So just to tell you about a complexity, if a refinery is not provided with input oil, I mean, if the crude oil doesn't reach the refinery on time, if at all the refinery shut, it takes nearly 3 months for the refinery to start. So that is where the complexity is. We need to ensure that there's constant supply of crude oil or crude material that goes into the refinery. So again, here as well, there's lots of data like how much of supply is there, what is the tank capacity, and so forth. Many complexity in there. And the last part is more of a less risky one, wherein you actually transport this oil, petrol, whatever you generated to all the retailers. Again, here also you need to plan your supply such that data is, or rather not data, the oil is actually gone to the right place, the right time, and with the right quantity. So if you see all this widespread area, right from the exploration until it reaches the end customers, right, there's lots and lots of data that gets generated, and need to have sufficient, very good infrastructure that would actually support. Just to take you through what exactly it is. So this is actually this is called as upstream, which involves data extraction or oil extraction. Midstream is all about transportation to refineries, and the last one is the downstream, which is all about distribution of oil. So just to talk about what problems, and the reason I'm explaining this is just to give an introduction of how we could use machine learning's infrastructure present in Azure to solve all these problems. And I'll just talk about few of the capabilities, and which could show you how best or how convenient it is for Azure to use Azure for these kinds of problems. So just to talk about the problems, right? So in here, as I said, there's so much of data that gets generated. How do I find out there is hydrocarbon prospects here? So how do we, from the exploration data, from the radar data that has been gathered, how do we know? I mean, if it's just about classifying the data, if you notice in the previous session, we spoke about classification, right? There's so much of data here. I mean, you can't give a model too much of data or overfit it such that it will wrongly predict that there is oil here, or you should not also give very little data so that it will give a totally different results, because the amount of money that is spent in order to drill a oil well is enormous. It's close to millions. It goes to millions of dollars. So that is the criticality of how best you model your data so that you get the best results of it. That's where Chaitanya was stressing on how best we could train a model so that you get the best results out of it. Don't do overfit or don't do underfit. So, and in here, how do I optimize movement of crude oil? I mean, you need to find out where the demand is there. What kind of demand is there? Is it oil demand? Is it gas, or is it crude? How do I ensure that the path the ship takes is the more optimized, the least cost effective, and so forth. In here as well, in the refinery, how do I optimize production and ensure safety? Because safety is one other important point when it comes to refineries. There's lots of equipment, and of course, I would definitely, you might know the Gulf of Mexico incident that happened. Probably it happened when we were in schools. So it is just about one technician not properly fitting in a nut. So that was the cause. You would see the impact of how critical these equipments are, and what is the need, and what's the criticality in using machine learning to ensure that all these problems are solved. And the last one is the demand supply, so which is very common. So you need to optimize your demand and supply such that you're profited. So that's all about what are the different problems that are there. And before going into how it has been implemented, I'll just very briefly talk about what Azure is and what are all the services that it provides, so that the problem and the services become an input for our use cases, what comes later on. So Azure, as you may already know, it's a service, it's a cloud computing platform that Microsoft provides for hosting your application. So your application might require a website. It might be a college website that you want to host. Currently, you might host it in some server within the college, and there's lots of complexity that comes in, wherein uh, if at all the application is hosted, you need to ensure that the servers are switched on. There's enough cooling capabilities for the application. You need to ensure that there is redundancy. If one server goes down, you need to have another server for your college website to be on. You need to ensure that if 1,000 people log into your college website, you need to ensure that you have proper response to them. You need to add more servers to ensure that students do not get access denied issues or any other access related issues. So that is where Azure comes into picture, wherein the headache of hosting your application would be taken away from you and put into Azure data centers, so that you need not worry about what is needed to host your application, what the infrastructure required, what are the kind of servers that are needed. You need not worry about all of them. You just need to think about what application should do, how many students might log into your application, what all the functionalities that you would want to provide as part of the application. So that is what you would have to worry about. And then you pick and choose the different services that are present in Azure, whatever is needed for your application to work in. So for example, in here, we have there's three different cloud services, which at a very broad level. So what you see on the left-hand side is the Microsoft Azure, which consists of IaaS and PaaS capabilities. And there is SaaS capabilities, which is O365 or M365. So when it comes to software as a service, it's a very constrained environment wherein you would be able to do only data manipulation, and there would be functionalities that would be provided over that data for you to act on or use them for your convenience. So things like Power BI, Dynamic 365, Project Link, these come under O365 capabilities. Thereafter, there is PaaS, IaaS, and PaaS. IaaS is more of a virtual servers. So you actually go to Azure to provision certain servers where you host your college website, or you take PaaS services, which are something like in the backend, you would be given a set of compute resources which you don't have direct access, but you would have APIs for using which you would be able to host them. So the advantage of PaaS is that you would not be responsible for patching your servers, making it secure, and so forth. All that would be taken care by Microsoft itself, along with the availability constraints that they would agree to. So in IaaS, you would have total access to the VMs, and you would be able to log in and make some changes and install patches and so forth. Whereas in PaaS is a more constrained environment, but it would allow you to deploy and change your application setup and so forth. So just to show what the different capabilities in here are, for example, in an on-premise. So when I say on-premise, it would be like your college infrastructure where you have hosted your college website. So in there, you would be responsible for everything like networking, storage, the hard disk capability that is present in this server, virtualization, operating system, middleware, data, and application. All the things you would be responsible for. Whereas in Azure, which is the infrastructure and PaaS part of it, right? So what you see here is the support team management. The yellow color ones are actually managed by Microsoft. So in here, if you notice, right, the operating system, if you get a VM, you have access to the operating system to make changes, install patches, or make some driver changes or whatever is needed for. Whereas in PaaS, you would have access only to do some data manipulation and hosting the application. So much of the middleware, runtime, and all those things would be the responsibility of the Microsoft of the cloud hosting vendor, which is Microsoft, to maintain them. And last one is software as a service, wherein you would have complete the complete responsibility of everything, right, would lie with the vendor. You would be just using that data, creating that data, and deleting the net. Those are all the kind of operations that you do. That is what is the Azure application fitment. So lastly, I'll not go into much detail about this slide. So this is actually the services that Azure offers. So it has a wide range of services, right from compute, which is needed for servers kind of a setup, to storage, web application, analytics, data, automation, deployment, networking, all the service from end to end. Whatever is needed for an application to be hosted is all provided by Azure service catalog, so Azure services. So that's the robustness. I've just hardly captured part of the services, but there are many more which has not been in this particular slide. So this is where the machine learning part of it comes in. So if in the previous session you spoke about data classification, image classification, and so forth. Apart from that, there are many other, for example, computer vision, right? Computer vision is a service provided by Azure for you to help in something related to image, be it image classification, image detection, find out what is there in an image. Those are all the kind of services that it provides. So imagine if at all you would have to build this on your own, on your probably in your college servers, right? There's so much of hassle in installing the necessary packages, installing the right software, the operating system, and the required memory, and so forth. There's many requirements for you to make those projects. So all these things come inbuilt as a service within. I'll show you a few examples of what service means in the next set of examples, in some practical examples. But that is overall what this is. So we have primarily 4 different broad categories of this one. In that, I will actually cover computer vision and data decision, basically on decision, right? I'll create a Azure ML studio wherein you would be able to see how these services could be used. So I'll do computer vision, forms recognition, and Azure ML studio to show you how those services can be effectively used. So if you notice, right, there's services for speech as well. So something like translation or converting speech into text and classifying that text, whether someone is, for example, in case if there's a chat facility provided by the provided for the students, you would want to classify certain maybe what kind of chats that there, what is the broad category, what is the emotion. Those are all the kind of services that speech provides. Similarly, language as well, as I said, right? Translation and so forth. So that is a part of the cognitive skills. I'll show an example of all of them in the next. And this is the Azure ML part of it. So most of the sessions, most of the examples, whatever was discussed in the last session, right, could be actually implemented using Azure ML, which means to say that you need not think about what is needed for, I mean, of course, you need to think about, but you need not think about the infrastructure, the backend infrastructure that is needed for implementing some of the models that were discussed in the last session. So that is where the Azure ML Studio comes in. So it gives a wide range of services for you to help in building and training model, hyperparameter tuning. So tuning certain parameters within the model so that it'll give a much better results. Like it'll give all the different capabilities which would actually help you to analyze this information, which means to say you get a result, you do further training, you compare the previous result with the current result. There's lots and lots of things that are actually there when you actually think about a machine learning project. So all these things are actually given as part of the service itself. So experiments and pipelines. So you create a pipeline with various different activities. The deployment part is again the production part of it, wherein you actually deploy this model into production and thereafter use the services to get the necessary functionality. And there is a backend DevOps part of it, which is more about maintenance. All end-to-end service, what is needed, what is required for a machine learning project to work is provided by Azure ML, along with the other services that I spoke about earlier. So this is the Azure ML part of it. So now I'll quickly go on to the practical implementation of it. So this is one of the use cases. When I showed you an example of the exploration team who are actually involved in finding out oil in a specific geographic location, right? They're with the specific problem, wherein they have a set of different files, wherein they would want to actually find out what is the kind of activity that has been done on a specific location. So these kind of scenarios do happen in oil industry, wherein probably in 1900s, you might have gone into some remote location within India to drill oil. And at that specific point of time, right, you would have gathered some information, some data related to the work that you have done, the exploration that you have done, but couldn't proceed further because either could be an equipment disability. I mean, there could be equipment challenges and so forth, because of which you would not have continued. So there is actually a need for in this use case, right? You have old data which has been in the form of a PDF file, and that PDF file is having various different kinds of information. So if you see here, there is a completion report, well report, sunrise notice, drill diagrams. These are basically the example of a oil drill. So whenever you actually find that there's actually oil in a specific location, right? You create a drill diagram to find out what all the different different parameters, or basically the design of a oil drill which will be used for drilling the oil out of it. And there is this seismic section, those waves, whatever I was talking about, right? They actually look like this. If you notice, right, they are actually very complex. So there's lots of data that is in which only a domain expert can actually look through and verify that there is data. So these are all the kind of data that is needed used by geologists to actually determine whether oil is there. So it's just all about like a ECG wherein there's multiple different lines. And there's lots of noise that come in. So usually a domain expert would actually take each and every line, find out whether it is actually a valid line or not, and right click and delete. Those kind of activities are actually performed by the exploration team. So this is the use case. Exploration team have a data set containing PDF files that contain critical drilling information related to a specific region. So domain experts have to manually open each file to determine if there is if specific information exists in the PDF. The exercise is practically impossible considering the volume of files that are present. So you might have thousands of files. So it is practically impossible for a domain experts to open them, because they are actually very critical resources paid very hugely. So you would not want them to use their resources for opening files and finding out, doing their analysis. Need an extensible automated approach to extract information related to. So this is the use case. So there's a set of files, there are images that are present within them, and what you would have to do is you need to classify these images and extract data out of it. So that's the use case all about. So I'll just quickly show you how a machine learning model can be used. So in here, so this is an example of a custom vision data set. So I'll show you how this has been created. So I'm sure you might have actually logged into an Azure portal. So Azure portal looks something like this. So you would have to log into portal.azure.com in order for you to have a subscription and what all the resources that are present. So in here, you would see the different services that are present. So in here, if you notice, right, there's one cognitive services that are present. There's a machine learning service that is being used. There's a storage account that has been used, which is used for storing our files. Then there is a resource group, which is actually a kind of something like a container and so on. So if you go in here, right, so this is actually the service that is used for, which could be used for our use case, whatever I spoke about, wherein I would be able to classify or identify images. So if I go in here, this is a custom vision portal. So you will have an option to create multiple different projects. So I've created one such project, which I have actually used for training to get certain set of images. So what you see on the left hand side is actually the things that I have tried to train this on. The way you train is, again, if you notice, I've just uploaded very few images to train it. So in here, there is the example of well report. Let me show what a well report looks like, so that you would be able to. So this is how a well report looks like. So it just contains certain information about well, what are all the different parameters. So if you see lease number and many more, right, who created it and so forth. So this is an example of well report. Then there's something called as sunrise notice. This is again another kind of report wherein it holds certain information related to well data and so forth. And lastly, there is drill data. So in here, you will actually see examples of how a drill looks like. So this is how a drill, there's various different parameters that are present for a drill, and that needs to be actually captured or looked upon by the geologist to actually infer some information on that. So the use case is that I would have to train it. I'll show you how the training looks like. So it's just about very simply going into add button, and thereafter so I'll go in, and so I would add a tag. So this is actually the categorization part of it. So we spoke about image classification, right, in the previous sessions. So you need to create a model that will help you actually do image classification. So you have around 100 documents. You have different models that are there for actually training that model to give you a certain. So this is what it is. I mean, if you notice, right, it's actually very, very easy when it comes to Azure in order to train that as well. So in here, I'm going to give it a name as drill, and I will upload them. So it is done. So you would notice that there is actually 6 information related to the drill. And what you would have to do is you need to train this. You need to click on train to actually train the model for it to recognize the when drill information comes in next time, right? It would be able to drill. So I'll click on train, but it takes a very long time. Let me show you how the test looks like. So this is one other example. So if you notice, right, everything whatever is needed for you to create a machine learning project, right, is all there embedded within Azure. It's just about clicking, or else it would take a lot of effort to put in to make this happen. So in here, right, I will just take an example of I'll probably I've actually trained it to recognize well reports. So I'll just this is the test data itself. I'll just, so if you notice, there's see, you will get a probability here which says that well report is 79%, sunrise notices. So this is how the data or the output of a model looks like. So it will give you a probability saying that this could be well reports. It will definitely not say that this is 100. No, it does say that it is 100% well report as well uh, with a lot of training. But in here, right, it is just giving a possibility that this is actually a well report. Similarly, I'll probably go in and look for sunrise notice, right? So it said that sunrise notice is and just now I've uploaded a drilling information. Let me show you what happens when a drill goes in, right? So I'll just select, and since I have not given any tag or I've not trained the model for identifying drill information, right? It is actually saying that it is negative. Negative or other, you actually train the model to identify the fourth type, which is the non-relevant item. So that is what the negative part of it. So it is now saying that this is negative, which means the model is not trained. So what you would have to do is you need to, you're just, if you notice, right, these are all the drill information that you had actually uploaded. But you haven't trained. So you need to just click on this button and it'll start training. It'll take quite a while for the training to complete. But once after that training is complete, you would, when you go and do a quick test for by uploading a drill information, right? It'll actually classify that as a drill information. So and so if you notice, right, it is very, very convenient. I mean, in this examples that you had actually shared, right, what you actually need to do is you need to just extract the images that are present within it, then train the model with all the, go to the domain expert, understand what kind of images that you would want to classify, and just train, use the Azure services for you to classify them. So it's an end-to-end service which would help you do these things very, very quickly, rather than setting up servers, installing softwares, installing operating system, procuring servers to do this activity. All this hassle will not be there with you at all. So that's the advantage of having Azure, or rather any cloud provider as a service. These services are available in any cloud provider as well. Just giving an example of Azure as such. So this was one of the use cases wherein you had used the capabilities of Azure to do image classification, and you notice that it is very, very easy to do that. So it's still training. It will take a little while for it to happen. So I'll move on to the next slide. Considering, so in here, this is one other example wherein see you have this drill information, right? So I'm not sure if it is visible. So you have this drill information. This drill is having a lot of information that is present. And if you see this JSON that has been generated, right, these are all the key information that is actually needed from a drill for doing certain analysis, which means to say these are all basically images, and you know, right, it is not easy to extract some text value fields from a image. So you need something that would help you do it. So this is one of the service which will actually help you extract information from images. So the use cases is something like the exploration team have multiple drill diagrams obtained by field engineers. So field engineers have gone into a specific area. They have explored, they have analyzed the well data. They have gathered some information about the drill that has been put in that specific location. And that information is actually present here. So the exploration team have multiple data, and you would want an automated way in which you would be able to extract this information out of drill data and do some analysis out of it, which means to say opening each image, first of all, it is identifying drill information, which is done by the previous service to identify whether that specific is a drill service or not. And thereafter, it will all about identifying what the information that it is able to extract out of it. So this is one such example. For this, there is something called as form extraction service, which help you actually do extract form data from it. So this is I'll just show you quickly. So this is still training. So this is an example of the form service. So if you notice, right, this is the example of one of the sundry notice information that is present in here. And if you notice closely, go through it, right? So you would see that there's lots of information related to, well, who is the operator, what is the block number, OPD. I mean, these are all actually critical for actually generating. So, and if you notice the complexity, right, there's so much of data here. And if at all you are actually requested to write certain modules to extract data out of it, it is an extremely, extremely complex operation. But let's assume that you want to extract well location, which is actually present in here. All you have to do is you need to go in here, type well location. Okay, and then click on this and just highlight this and click back here. And if you notice, right, this actually comes in. So you've just told the model that this is a well location information. Similarly, right, you would have to do that in all the places. So this is one other example where this on. So you would have to click on here, then go here and click back again. So this comes in. You'll go to the third diagram again. So in here you go, then click and click back, and I'll do it for 2 more, and I'll show you how the training happens. Again, this is also a model which will help you do it. So in here, I'll go here, this, and click on back again. And the last one is this one. Actually, this time, whatever it takes for training, right? It is all about what kind of services you have actually taken. You have definitely have some dedicated services which makes things faster, but that's a lot. That's more cost to the company. So what you have done here is you have within minutes or within seconds, you have actually trained a model to extract certain section of the document to extract well location information. So what you have to do is you need to click on the train results to get in order to train. But I'll just show you the output what it comes without the well location, right? I'll just take an example of sundry notice. So I'll just click on this and click on open. So I'll click on run analysis. So it takes a little while for the output to come, but what is happening in the backend is it is actually taking this data. And if you notice, right, all this, whatever, let's assume that this is a new image. So it has actually extracted the key things what you have actually trained the model with, right? So it'll just a second, sorry. Yeah, sorry about that. So it is within minutes, right? You have actually trained a model to identify, analyze an image and extract field data out of it. So, and in order to identify the news, so if you notice, right, the other things like well location was not identified. That's because you have actually not trained it. So it's all about going here and clicking on the train button. All these actions, whatever I'm doing using click operation, right? It can be automated as well. It can be actually done through scripts as well. So it is actually training in the backend. So after some time, right, it will be able to extract additional fields as well, which is the well location. So this is actually the forms extraction. I'll just see if the training is completed for the customization. So yeah, iteration, it is actually completed. So this is the then you do a quick test. Now you actually do a browse. So you go to drill. So let's see what happens now. So if you notice, last time it had actually shown this as negative, and now it is actually showing this as a drill information. So it's just in few clicks you have actually trained a specific model to identify a new set of images, whatever is needed for the domain expert. So we have covered 2 things. One is image classification and the forms recognition. The last part of it is actually related to I'll explain the last part of it, which is actually the prevention of blowout. So this again is related to health and safety. So if you notice, right, these are all actually oil rigs which actually take oil out of the Earth's crust. So there's lots of, so if I had shown the example of a drill image earlier, right, there's lots of sensors that has been put within the well, which would actually determine the force with which the data comes. I'm sure you might have drilled bore wells, and when the borewell is drilled, there's water that comes out of it, right? So it comes with a certain pressure, and if you talk to these people, they say that it is 1 inch, 2 inch, and so forth. That's the water that has been found, which is actually an indicator of how much of, with what force the water is coming through. So that's the more it comes, when it comes to water, is actually good, but when it comes to oil, right, this has to be controlled. So in case if it is not controlled, right, there are two things which could happen. One is the pressure would fall to such an extent that you will not be able to drill oil out of it, or it becomes too much so that it just comes out of it. So, and you will see this hazards which happen wherein a specific location is all flooded with oil data and oil and so forth, right? So those are all the complexity, and it will also help in supply and demand, right? So depending on how much oil is coming out, you actually plan your supply to the refineries as well. So which is ensuring that the ships are there to carry your data, carry your oil to a specific location, and the refineries are there. And refineries further will have the retail customers as well. So it's all linked. I mean, if you go wrong here, the entire your pipeline is actually obstructed, which will cause too much of a loss. So you need to have sufficient models or sufficient sensors with models which actually predict that this safety is actually taken care. So this is what I'm actually explaining here. In here, right, volume of oil from exploration is unpredictable. Oil flow out of exploration will have to be carefully controlled and monitored to ensure maximum profit. Well blowouts may happen if the oil flow is not controlled, leading to environmental contamination and accidental deaths. Sensor information from wells have to be monitored for anomalies to take corrective action. So this is the use case. So I'll just show you how Azure ML is actually used. So this is an example of a data classification. So you have certain parameters that you have actually gathered from various sensors in the drill, and you would want to use this to actually classify whether the data is actually overflow, underflow, or normal flow. So that is the use case. So I'll just show you how it would look like. So in here, right, oil data. So in here, so this is how the data looks like. So these are all the different sensors. Actually, I've actually masked this information from our previous clients, wherein there's no confidential data. Some of the units have been morphed, and even the values here, right, are actually morphed to just show what is the use case and how we would be able to address it. So in here, right, these are all the different sensors, and these are all the different values that are coming. And depending on this, right, from past experience, from past data that you have gathered, right, if at all the values are like this, you will get a high oil flow, which means you need to take sufficient care to handle this. Similarly, these are all the different option. These are all data when things will be. And the last one is actually the low oil flow, which means your supply chain might be affected when low data comes and so forth. I've made it very, very simple just to explain the concepts. Actually, it is actually not as simple as what I'm actually showing, because there's lots of mathematical models that are actually were very, very, very complex to actually predict what I'm actually telling of. There's so many different sensor information, so many other data that goes into predicting. But what I'm actually trying to explain here is actually a very, very, very simplistic representation of what it actually looks like. So this is your use case, and there's something called as Azure Machine Learning Service, which we can actually use for training the model. So I'll just show you that. So in here, this is the Machine Learning Studio. So I've actually created a model. So whatever Chaitanya was explaining in the last, using those models, right? I've used the Azure Infrastructure Service and use model, which few of the ones which Chaitanya spoke about in the last meeting, to actually create or train a model for which I'll give the input and get the results out of it. So I've done a very, very minimal minimal input to the system. So I'll probably explain how this machine learning is used. But before that, right, I just wanted to show you how, let's assume that the training is all completed in the backend and we have deployed the model and it is exposing a service. So if you just go in here, right, this model is actually deployed and you actually use a test approach. So whatever parameters I have actually explained, right, in the earlier example while showing the data, it's all there here. So if you imagine the complexity here, right, see, your data can be very diverse. You have n different number of columns, but this infrastructure is actually giving you a service where you actually can represent those columns and give values and actually test. So in here, for example, you have an option to upload CSVs as well. So in here, right, in this example, so I've indicated 2 as overflow, 1 as normal flow, and the zeros as lower flow. So that's the column that needs to be predicted. So I'm just taken this medium ones as an input. So I will just go here and just replace them and actually check. So it will say that these are all actually normal flow. Right, and there was a question on what is under training, right? So I've actually trained it with only these many set of models, this much data. So in case if I just give this one, which is supposed to show as low, right? So I'll just show what. So I'll just click on test. So it still said 1, which is actually not right. It has to be 0 as per your data, but it is actually shown. Wait, why does this happen? This is the same thing as overfitting and underfitting. So you have trained the model with very, very little data, because of which it is actually giving, because of which it is actually giving wrong results. So this again is all about how you ensure that the right mix is that when you study about data science, right, you will know about techniques as to how you can model your data that needs to be used for training here and so forth. So again, this is actually the machine learning studio, which I just spoke about. Since I have very little time, I'll just very quickly show. So in here, you just, this is one of the services wherein you go click on create Azure model. This is the ML model. This is exactly what all models were explained earlier, right? All these things come as click of a button in this Azure services. So that's more or less what I wanted to cover. It's a lot of topic, but I hope I've explained it so that it's enough information for you. Thank you so much for your time.
Thank you, sir. So thank you for the very interesting session on how the machine learning can be used for in this oil refineries.
Thank you. Yeah.
Sir, I have one doubt.
Yeah.
What type of algorithms you use for this type of data?
So that's what, see, in the previous example, we spoke about many different services, right? So I'll just show you. So let's assume that this is what is the input data. This is the Excel sheet that has been discussed here. So in here, this service gives you all the different models, be it whatever it is, right? It gives all the different options for creating your model for training that. So in here, this is oil flow. I'll just click on. So see, if you notice here, right, you have different kind of models like classification, regression, and time series forecasting, and so on. So let's assume that this is this one. So when you go further down within it, right, you have an option for selecting the different models. So in here, you would have options to actually add models and so forth. So that is what is the capabilities of Azure that will help you to do this. So you have to answer your simple answer to your question is any model that you have read about, right? Most likely it would be actually supported in Azure using this steps, whatever I spoke about, right? You would be able to use the machine learning model.
Sir, because accuracy, I think it's very important in a field like this.
Correct.
Then can we use any type of model?
Yeah, of course. I mean, it's all about your analysis, right? It's all about how much of analysis, how much of data you would get, how much of training you would do, what are all the resources that you are having in order to do that. All comes into effect. It is whatever I was just showing is one of the most simplistic way of actually handling it. But things are actually even more complex. I mean, it could be that, for example, the image classification that I spoke about, right? It might start giving wrong results. So how will you handle that? So one of the ways is you might have seen those percentage, whatever is there on you capture that, put that in a report. You review the report saying that, okay, there are certain set of images where it says that the input or the identifying the probability is shown as very low. That means we have not trained our model to identify this image. Go in, retrain, republish. So all these things, right? It is, and the added complexity is, right, you might have millions of images. So you would have to plan how you would do training of this billion, not training of classification of this billion documents. How much time does it take? How will you ensure that you do them within a week or within a month? So all this are all the complexities that come along with it. So what we are showing is just an example of how things could be used, and be it any model. So you might select a different model which shows more accurate results. So the 0, 1, and 2 that I showed about, right? It was based on probably a decision tree that I had actually selected. But you can probably do a much different model classification, run them to see check the results to see whether it is properly classifying or not. So it's all about, as you said, right? Accuracy and training, retraining, analyzing, ensuring that the right results are coming from the model. So that's all. That's all it is all about.
Yes, sir, thank you. Does anyone has any other questions? If you have any questions, you can raise your hand. Okay, you can unmute.
Good evening, sir. Good evening, sir.
Good
It is a wonderful information session, sir. I have a very
Thank
small doubt.
Yeah.
Whether Azure allows for a free or free version, sir?
I'm pretty much sure educational institutes are given free subscriptions. From whatever I've seen, I mean, I've gone through a few conferences where things related to educational institutes, right? Particularly students and so forth, right? They've been given free subscription for you to try out things. But I'm not up to date on that. But definitely, I'm sure that Microsoft has some special consideration for educational institutes.
Okay.
Yeah.
Okay, sir. And regarding to with another doubt, sir, which may not be related to this, I'm interested to work with the bot framework.
Okay.
Right. I'm building about this
Correct.
chat kind of thing.
Correct.
Bots.
Right.
How I should go about with this?
See, I was actually talking about speech and text analytics, right? So in here, you would actually see. So you ask a question. It is all about language understanding.
Yes, sir.
So let's assume that you create a bot for your students.
Yes.
So let's assume that you might want a student might ask, give me the procedure for admission to the college.
Yes, sir.
Right.
Exactly.
So he has typed this, give me instruction on admission to the college is the question. Another person might ask, what is the admission procedure?
Yes.
Another person might ask, what are all the different steps that we would have to follow to get an admission into your college?
Yes, sir, right.
There are all different ways of asking the question.
Yes, sir.
But the intention is all the same thing, saying that I want to know about admission procedure.
Yes, exactly.
So when different users ask this, you would have to show one paragraph saying that please follow this link for admission procedure, or these are all the steps you would want to show in your bot. So
Yes.
in those things, right? So if you notice, right, Q&A
Yes.
maker, language
Yes.
understanding,
Language.
these are all the things that actually you use for doing that. And it's, I mean, a very simple bot can be created within minutes
Yes.
if you use those services actually.
Okay.
So if
Okay,
you go through this, right, most of very common things that a normal person or a normal requirement is needed, right? That's all covered here.
Sir.
Because the example I showed, right, you might see that it is very complex when it actually comes to model development, but Microsoft has given certain capabilities which would make things very simple for you to do that.
Okay, sir.
Yeah.
Okay. Yes, sir. Thank you, sir.
Thank you.
Sir, I have one more question.
Yeah.
Like what type of models can be used for time series prediction or when we are working with time series?
So there are quite a number of models which were actually related to logistic regressions. I don't have things in my mind, but if you notice this logistic regression models, right? You would be able to use them for actually doing machine learning models related to them. So I don't have it now, but yeah, we could use any of these things.
Okay, sir.
Yeah.
Sir, can you please turn off your screen?
Okay. Yeah.
Can you please switch on your video?
Oh yeah, sure. Yeah.
Hello.
For a
Good
very
evening, sir.
informative session.
Sir, good evening, sir.
Good evening, sir.
Sir, underfitting is inversely proportional to accuracy. What are the remaining factors that can influence accuracy? Whether they are depending on the case study?
No, see, it's when it's not only underfitting or overfitting that matters the accuracy of the results. It is also about how diverse is your data set all about. So in the example that I spoke about, I had just shown you example of 4 different variables, right? So just with those 4 variables, I've just shown a very simple experiment. But if at all you saw an example of that drill information, right? There are hundreds of different sensors. All these 100 different sensors give you certain data. Does it mean that you take all the 100 columns for your model training? No, because certain things, right? So there might be pressure valve 1 and pressure valve 2. Both are actually synchronously raising or synchronously coming down. So in those cases, right, you would not have to select or give both the columns as input, because it will be too much of data for the model to actually learn from them, and the accuracy results may actually drop. So in order to ensure that you have sufficiently properly input data, right? Those number of columns or number of input data has to be decided. That's also a very critical activity for the accuracy. And of course, in the example that I showed you, right, there might be certain peaks as well, which are called as outliers. Right, they actually severely affect the model. So for some reason, the sensors, right, might give you a very high value for a very short duration. Does that mean that the oil is actually coming out with a very high pressure? No. That's the answer is no. That's what your mathematical models, right, will actually consider those things as well. So in case the sensor gives you wrong data for a certain amount of time, how do you manage it? So you might have studied a bit about first quantile, second quantile, third quantile, fourth quantile. These are all different techniques wherein you actually divide the output that is coming and analyze it over a period of time, so that it doesn't cause any damage to the environment. So you actually study it. After a while, it might go down. So your model should be able to handle all these different scenarios.
Okay, sir. Thank you.
Any other questions from the participants? Okay, thank you.
Thank you.
As a token of appreciation and gratitude, I request our coordinator, Dr. R.N.V. Jagan Mohan sir, to present an e-memento to you.
Thank you. Thank you so much. It's really an honor to speak to you, and thanks for the opportunity as well for talking to you all. It's really an honor to me. I really enjoyed it a lot.
Thank you, sir.
Thank you.
Sir?
Yeah, can I log off?
Yes, sir.
Thank you so much. Thank you so much, all. Thank you all once again. Thank you.
Dear participants, we are going to send the feedback links in the chat window. All of you give the feedback. Today we are going to give 2 links because we are having 2 resource persons in today's session.